Welcome. Always nice to stand in front of a big crowd. I'm really happy to see loads of familiar faces, but also some unknown faces. We are here to tell you a little bit about our assembly planning solution that we, in collaboration with Cadmatic, have developed, and also with some other partners. But before we dive into our conversation, we want to start off with a video, because images say more than words.
Seaspan Shipyards is one of the most modern shipbuilding, repair, and refit operations in North America, with a long-standing reputation for world-class service. Our 3 shipyards are strategically located in the Pacific Northwest to undertake some of the largest and most complex projects for government and commercial customers. Vancouver Shipyards is the prime shipbuilding site for the construction of large non-combat vessels under Canada's National Shipbuilding Strategy program. Victoria Shipyards operates at the federally owned Esquimalt Graving Dock, a 25-acre production site with access to 1,900 feet of deepwater wharfage. Vancouver Dry Dock operates floating dry docks with lifting capacities up to 36,000 tons and is equipped for quality repair services to a range of vessels. The combined capacity of our 3 shipyards allows for the simultaneous construction, repair, and refurbishment work for naval, research, and commercial vessels. Seaspan Shipyards is making waves rebuilding an industry that is integral to Canada's security and sovereignty as part of the National Shipbuilding Strategy. We're securing long-term job opportunities and building supply chain partnerships across the country to deliver the next generation of technologically advanced ships for the Canadian Coast Guard and Royal Canadian Navy, driving substantial economic growth as we recapitalize our nation's industry. Our skilled and diverse workforce is at the helm of our operation and embody a culture of belonging that is respectful, inclusive, and reflective of all the people who live in our region. We collaborate with Indigenous communities on a vision for progress based on relationships, environmental stewardship, and sustainable development. Partnering with organizations like the Aboriginal Community Career Employment Services Society, we're creating career pathways for neighboring communities for generations to come. We're dedicated to environmental stewardship, playing an active role in multiple local community conservation initiatives and restoration projects. And we're serious about doing our part within our operations, from waste management to energy savings initiatives to emissions reductions. Safety is at the heart of everything we do. It underlines our continuous drive for improvement across the business to responsibly deliver best-in-class solutions to our customers. Our reputation for excellence is the result of unwavering teamwork across our dedicated workforce of more than 4,000 employees. Together, we're ensuring that ships built for Canada are built in Canada as we strive to become the recognized leader in the shipbuilding and ship repair industry around the world.
Okay, so I do hope you enjoyed that little introduction to Seaspan and a view of all our 3 shipyards. So I'll quickly just go over some of the projects that we've been working on, some already completed and some are in progress. So starting from the left, back in 2011, under the Canada National Shipbuilding Strategy, Seaspan Shipyards was awarded a contract to build some vessels for the Canadian Coast Guard as well as the Canadian Navy. So we have built a number of them. So starting from the left, we have the offshore fisheries science vessels. So we built 3 of those. The first one was started in 2015 and was completed around 2017. And then the second one was started 2017, was completed around 2018. And the third vessel started around 2018 and was completed in 2020. So as you can see, it took just about 5 years to build all the 3 vessels. It took us a little bit longer because we're a young shipyard. Lots of challenges, lots of growing, lots of process changes, lots of systems that went into that. And then we have the joint support ship. So we had contract to build 2 of those. The first one started building in 2018, We just launched it last December 2024, and it's now in the water to be delivered to Canada later this year. The second JSS ship is under construction, and that's scheduled to be delivered in 2027. And in between the JSS-1 and JSS-2, we also built the oceanographic science vessel, and that was completed in August of last year. It's also in the water, and it's going to be delivered at the end of this year. And then we have the Polar Icebreaker, which is the heaviest vessel ever built on Canadian soil. We started construction on that in April of this year, and that's scheduled to be delivered in 2029. And then we have the multi-purpose vessels. We've changed the name to multi-purpose icebreakers. We have a contract to build 16 of those, and functional design work is started on those, and the first vessel is scheduled to be delivered in 2030, and the plan is to probably build that sister ship capability so that we are delivering one ship every year thereafter. So we've been busy, and we're still busy as a yard, and just a little bit of what we're doing right now. And then just a little bit of background on why the assembly planning solution. So primarily, our company has been planning from a 3D visual planning method. And with the implementation of Cadmatic, we wanted to maintain this 3D visual planning because of downstream systems, including our ERP. So the data structure for the ERP is based on a 3D model, and we wanted to maintain that without, we wanted to use Cadmatic, but also maintain that data model so that we don't change our downstream processes.
Yeah, thanks, Maureen. So let's start with our definition on what is assembly planning, so everybody has a good understanding what we're trying to achieve. So in the end, assembly planning is basically translating our E-BOM to our M-BOM. So really the output from detailed design into actually a production readiness bill of material. This process that includes, to that extent, the definitions of our work packages that are involved with that. There's also like parent-child sequencing of those structures, but also component parts and product types, such as panel, bulkheads, but also like brackets, have been discussed around here, but also labor types, so our trade labor types, allocation. So it's really having that translation from E-BOM to M-BOM altogether. So why did we need to change our current way or our previous ways of working? With the ship types that Maureen was just telling, we designed and built the first 3 ship types in a different CAD tooling, ship constructor. With Polar and the MPIs actually coming on board, we also changed that whole upfront tooling. So we changed the ways of working, but we still had actually our back-end process set up in a similar way. So we needed to establish actually, through that implementation, the missing capabilities that Cadmatic wasn't delivering, which Ship Constructor did have. We also concluded that Ship Constructor, even though it had good visual planning capabilities, it was a very manual process. So it was also not really efficient. So we also identified the possibilities to leverage automation possibilities, but also we want to leverage the possibilities of the drawing structure change, moving from a one-to-one relationships, one drawing, one work package, to a one-to-many, which then also opened up our way to actually have a PLM-centric BOM direction. So prior to that fact, we weren't managing all our BOM-related data through our PLM solution, which then was also a driver from us to actually revisit actually that whole solution. So how did that previous planning process look like? We've tried to keep it a little bit simple and high level, but this is actually reflecting what I was telling you just at the previous slide. It was a highly manual process where we would actually have our production design and pre-production done within Ship Constructor, but with actually manual integrations by scripting or either manual checks into our PLM software of our engineering BOM release data. We then had an Excel-based kind of extract to actually load into our ERP solution. These elements really required a lot of manual interventions, manual checks, semantics, checks on attributes, completeness. But also there was no direct connection between our PLM source of truth, looking at our EBOM, but also versus actually what our MBOM looked like in our ERP. So obviously everybody here has a fairly good understanding what that means. You have a big chance on deviations, but also a possibility of deviation between what you have designed and what is actually being built, and no possibilities to really easily check that in between. So a lot of challenges in this process, even though with all the manual interventions, we were actually able to manage that, but that obviously created inefficiencies. So looking at the new assembly planning process, and maybe for Marcus as well, obviously we have developed this all together, but you mentioned as well in your presentation, looking at an assembly planning process and visual planning capabilities, obviously we have developed that together with yourself. So in that new assembly planning process, you can see that we are actually going through the different modules of Cadmatic with eShare, a whole, and with Plan Modder for outfitting. We establish in that direction a more automated and semi-automated solution until actually our ERP release, which we'll touch upon later. That 100% and semi-automated solution actually brought us more quality checks capabilities, automated checks, but also with the scripting that we established in the assembly planning solution, we have an automated solution to allocate actually parts based upon the attributions that we have, the relationships from the model, and to allocate it actually to have that actually connected. We also have that E and MBOM configuration control possibility by actually establishing that layer within our PLM solution, which we use Aris Innovator for. We are, by doing so, are also able to finalizing actually that MBOM to that extent, and to be able then to have that output delivered to load in our ERP. That final step is still a manual step, 100%. The reason that it's still manual is because we're, at this moment in time, still using a legacy ERP system, IFS. Some of you are also familiar with that system, and we're in the midst of actually replacing that. So we pushed that decision out to the new ERP, which will be going live next year in February, to actually also automate that step. So what does that bring as well from like a quality check performance? By automating actually this process, we have established within this whole solution automated quality checks that are being performed between the different steps, which will allow us actually to check on the data and the process quality measurements. And previously, it was all done manually. We have some examples of those automated checks. So we have like rules based on stage of construction, or SOX, and trade allocation. We also have an attribute comparison that takes place, which status checks on the relationships validations on our EBOM. We also have quality checks on missing data elements, such as missing parts, status of parts, and also the latest versions checks. And in the end, we're also checking on sufficient data maturity on attribution and other elements. So comparing this with our previous state, this is now all done, automated, and no manual interventions need to be in place, besides actually consuming the outputs of these checks as well.
Looking at the hull, just touching briefly on some technical details that we developed. So we wanted to leverage Cadmatic out-of-box solution as much as possible using the work breakdown shop manager. So this provides functionalities such as automatic grouping for structural products, such as bulkheads and panels and sub-panels. It also provides that interactive visual planning via the hull viewer, and also allows that functionality for user interface drag and drop for sequencing. So we wanted to maintain that functionality, but also did some customization on top of that, which essentially pulled the physical characteristics, and then which assisted in workstation assignment, as well as assigning to various stages of construction and automated name completion. What this has helped us achieve is moving away from that manual, error-prone process where the planners would pick parts and assemble them manually. So now we have that automated process that, that it goes through, as well as ability to move groups of parts instead of individual parts like we were doing before. And then this development essentially has been incorporated within the Cadmatic suite as a shop manager for the assembly planning process. So big development there. And this is all in-house development as well.
Looking at the outfitting solution, there was actually a little bit more of development that needed to take place. So within the Cadmatic suite, there was no baseline visual outfitting solution available. So we went together to explore with Cadmatic what that actually meant to develop that. So we actually divided it into two buckets. So we first had, from a scripting perspective in Plant Modeler, we established automated planning scripts to allocate the SOC and the labor trades, so the trade labor types. So looking at our SOC definition, so we have different stage of constructions. Actually, our shipyard is planned out into the different SOCs. And obviously, you want to allocate actually the different components from your model to the different stages of construction, so you can actually already plan that ahead. But also looking at the different trades that you want to actually be able to connect to those work packages, so you can already plan them ahead of time as well. Within our yard, we make usage of many different trades and many different workers to trades. So it is also of essential, it's an essential element actually, to actually have that information up front to be able to plan that. So next to the planning scripts, we have now all model outfitting parts processed automatically through those scripts. And by doing so, we actually have established that we have 80% from the outfit planning done automatically, but we're still looking as well for actually to compile with the remaining 20%. So that's kind of a work in progress, and also the maturity ladder that we're climbing. And with refining actually the rules over time that are actually feeding those scripts. And we also have the 3D visual model-based outfitting planning capability, which is also now added to that standard solution and suite of Cadmatic. Besides that, we also had the eShare development that has taken place. So we have the 3D assembling definition of object grouping functionality that has been implemented, and we have an integration script to push the assembly groups to the plant modeler. So you would see it like eShare is actually taking out that visual planning capability from actually plant modeler, and then actually feeding that back in to the outfitting model. It's based, or it's connected through the standard web API. So also reflecting to the earlier presentation within Wave, this is now through the web API to our Errors Innovator. And in the end, there's also capabilities to use this within the drawing creation if needed.
So looking at the PLM, we did some development as well. We wanted to integrate these two systems, our Cadmatic system as well as with our PLM system, to allow for that data to move between the systems. So this was a real-time development initially, where information was moving. When parts are getting deleted, it would reflect in the other system almost immediately, and vice versa. And if you're editing or adding or changing anything, that would reflect in a PLM system or Cadmatic, like in real time. But what that did also, it created a bit of a problem. So when you putting the packages together, when you're building that assembly, and somebody ends up changing the part in Cadmatic, so there you already missed something. So it ended up being some inconsistent information. Vice versa, if something was added, then it's ended up being missed in this package. So what we did was build this tool, it's called Cadmatic Import Tool, that allowed us to import information from Cadmatic, let it sit at a staging area where the planner would go in and verify the information, and if it deemed correct, then they will commit, and then it goes into their PLM system. If there's any changes that have happened, deletions, this tool will trigger an automatically change request that would go through the change process and then come back and gets committed. So it's essentially just a staging area that kind of views that information, and so that we make sure that the right information is going into the planning to create that EBOM. And then that eventually becomes MBOM, and like Pieter-Paul mentioned, there's a manual process where we import it into the ERP system, but because that's changing, that's on hold. But eventually the goal is to have that end-to-end capability where information is flowing from Cadmatic, sits over here, somebody verifies it, and then it flows into the PLM system, and eventually flows into the MRP. So creating that end-to-end visibility.
So looking at it from a core capability perspective, so within this slide, you can see like in all the gray bars, these were all the capabilities that we already actually had implemented, and I wasn't part of that conference, but 2 years back, also presented by our colleagues, Mohammed and Spencer. But with the assembly planning project, we actually added those planning capabilities to that landscape. Obviously, this is a huge step for us actually to not only having this more automated to the 100% and semi-automated way, and also with the outlook of integrating it with our ERP landscape. But it also still opens up, the challenges that we are together need to overcome with Cadmatic. So looking at from like an integrated models between whole and plant modeler, there's still a lot of advantages actually to integrate that more thoroughly, because that is also actually, impacting downstream how it's seamlessly integrated from a planning perspective. Secondly, there is also from an assembly hierarchy, there are some limitations to it, and to what level of depth you can go. There are more capabilities similar in ERP landscape, which are reflecting to a deeper level of assemblies, which are also could be beneficial actually for this process and for our needs. And then we also have some of the capabilities that we have on the roadmap that we're currently working on. So starting off with actually the top, the bottom one, the drawing highlighter. So Marcus was already actually reflecting to some of these capabilities, which we're also actually now looking into our eShare stack to implementing actually the highlighting capabilities to be able to visualize what has been already allocated to work packages, but also to have actually production data feeding back into actually your 3D model view on stage of construction, to be able, if actually some of the components are already installed or work in progress or actually still planned for. So these capabilities are a big advantage for us to bring that actually to the work floor, the shop floor. And that also actually ties into actually the other capability they were really, looking for. I'm bucking Juan heavily on this, is on actually the iPad visualization. So we want to aim as well to go for a paperless yard, and we already have 500 or more iPads actually in the yard that are being used by all the trades and the workforce and supervisors. Obviously, this also we also want to push eShare actually into the yard, but it also requires actually that compatibility of eShare with those iPads. So this is really for us a key, primary topic, I would say, not only for the last recent weeks, but already for a long time. Then, as a final slide, so from a project outcome, I think that we, together with Cadmatic, have really established a huge improvement in our process and the solution that's supporting that solution. It hasn't not only created more efficiency, but it also has created a huge improvement on our data integrity, or actually the possibilities to flag those data quality integrity challenges. By doing so, we have that integrated end-to-end design to planning process, a fully visual 3D planning from structure to outfit, and in the end, a substantial automation of our planning. So reducing the repetitive actions, checks for planners, but also other people in the workforce, and has a huge benefit actually to the downstream processes. So by doing so, we tend to say that we're ready, or we are already building Polar and ready to start building the MPIs as well. Thank you.